All right, to help us out with this section, we're going to go through this little warm-up. So if we're asked to evaluate f of 4, given that f of x is this function, all we're going to do is plug in 4 everywhere we see x, right? So f of 4 would then become 4 squared minus 4 times 4 plus 1, which would simplify to give us 1. All right, so what's really cool about functions is that we can perform operations on them. All right, we can add them, subtract them, multiply, divide, and we're going to introduce something new called composition of functions that might take a second to wrap your minds around, but I'm hoping that we'll be able to work with it, okay? So we want to be able to do all of these things, okay? Sum, difference, product, and quotient. That's going to be pretty straightforward for us. All right, composition and domain and range for those compositions, it's going to be a little bit new, okay? So we want to be careful with the domain when we're dividing or when we're working with square root functions. All right, so in this example, let f of x equal x squared minus 4 and let g of x equal 2x plus 1. We're going to find the following. So you'll typically be given two functions. First thing we're going to do is state the domain of each. All right, and I'm going to ask that you write this in interval notation because these are continuous functions. Continuous means that we can plug in all sorts of decimals in between our integers. All right, so think about what numbers are you able to plug in for x here. Can you square a positive number? Yes, like 1, right? You could square that, that's fine. Could you square a negative 1? Yes. What about a fraction? Could you square 1/2? Yes. What about a negative fraction? Yes. Okay, so nothing is going to make this f function be undefined, so we're able to plug in all real numbers. All right, so the way we represent that in interval notation is from negative infinity to infinity. In other contexts, you may see it written like this, an R with like a double bar that represents all real numbers. All right. Domain of g of x, so 2x plus 1 right here. We can take any number, any real number, and plug it in for x there. So again, we're going to have all real numbers from negative infinity to positive infinity. Remember, we want to put parentheses around both of those, and we want to put a comma in between them. All right, so taking a look at this example, so working with these two functions, f of x equals x squared minus 4 and g of x equals 2x plus 1, we can actually add those functions together. Okay, so this notation is what we're looking at. F plus g of x is the same thing as f of x plus g of x. So all we're going to do is just take our f function, which was x squared minus 4, and we're going to add our g of x function to it. Okay, 2x plus 1. And now we just combine like terms, okay, and write it in standard form. X squared plus 2x minus 3 is our sum of those two functions. Okay, I don't really care about this notation so much, but just to be consistent, we can write it out. For the domain of this sum function, we want to see what were the domains of our original functions. Okay, both all real numbers. And then looking at our resulting function, do we have any other restrictions we need to keep in mind? No, we don't. So we're just from negative infinity to positive infinity. All right, we can subtract as well. Just be careful with your signs. We'll take x squared minus 4 minus the quantity 2x plus 1. If you put parentheses, you're less likely to make a sign error. And we end up with x squared minus 2x minus, so if we distribute this negative here, it becomes negative 1. So we end up with a negative 5. And our domain, again, will be negative infinity to positive infinity because our resulting function, we can plug anything in for x here, all real numbers. And both of our original functions also had domains that were all real numbers. Okay, next example, if we look at multiplying, all right, if we look at multiplying, we're just going to set up our two functions. All right, it's like saying f of x times g of x, okay? And so we can take x squared minus 4 times 2x plus 1, distribute, right? First, outside, inside, last, and we end up with 2x to the third power plus x squared minus 8x minus 4. And for our domain, what were the domains of our original functions? Think way back here, right? Oh, darn it, just erased my last step. Minus 8x minus 4. All right, think back to our original two functions. They both had domains of negative infinity to positive infinity. So this product, if we don't have any other restrictions, then it's going to stay the same, okay? Negative infinity to positive infinity. And I know that there are no other restrictions because I'm looking at these x's, and I can plug anything in for x. Okay, I can plug in negative numbers, positive numbers, whole numbers, integers, irrational numbers. All right, I can plug in any real number there. So for domain, the big thing we want to keep in mind is we're asking ourselves, what can't x be? Okay, and then in interval notation, we are going to remove that value for x from the possibilities in interval notation. Okay, we're going to choose the most restrictive domain when we're working with functions. And that typically comes into play when we see division. Okay, so f divided by g of x is the same thing as f of x divided by g of x. Okay, so we can just take our two functions that we started with, x squared minus 4, divided by 2x plus 1. Okay, that's our function. Now, when we think about what can't x be, the operation of division is not defined when 0 is what we're dividing by, right? So we need to make sure that this denominator is never equal to 0. All right, so we need to make sure that this denominator is never equal to 0. So if we solve this just like we would a linear equation, we'll end up seeing x cannot be equal to negative 1/2. Okay, so we can plug in any other number for x here except for negative 1/2. So here's how we're going to represent that in interval notation. All right, we want to think about our number line, right? Negative, 3, negative 2, negative 1, 1, 2, and 3. Number lines go on forever. Let's put some arrows there. So when we think about our interval, anything from negative infinity is fine. Okay. Then where does negative 1/2 fall? It falls like right here. Okay. We want to remove that. Okay. And then we'll just continue on with our interval. So the way we're going to represent that is from negative infinity, comma, negative 1/2. Use a parenthesis. Union, so we're going to skip over that negative 1/2, union, parenthesis, negative 1/2, comma, positive infinity. Okay, so this domain is just representing x not equal to negative 1/2. Another way we could represent this, if we're in set builder notation, we could open up our squiggly brackets, and we could say x can be, so x exists in the set of real numbers, such that x is not equal to negative 1/2, okay? We're typically going to stick with interval notation in here, but this bottom set builder is what you'll see if you move forward in your mathematics careers, okay? So that's adding, subtracting, multiplying, dividing, and the domains that follow. I'm going to make a new video here to talk about compositions.